let's review the sections that we've talked about so far. So sections 2.1 and 2.2. So remember in section 2.1, one of the things that we looked at was a diagram, and we needed to identify different pieces from the diagram. So we're going to use the diagram on the right to answer the following. We want to state the domain. So remember, domain deals with your x values. So if I'm looking at the graph, I read it from left to right. I see on the left, I have an arrow. I see on the right, I have an arrow. So that tells me that I'm going to keep going to the left. I'm going to keep going to the right. So as far as my values for x, my domain goes from negative infinity to positive infinity. If I'm looking at my range is dealing with my y values. So if I look down to up, because I want to go from negative to positive, I see going down, I have an arrow. So that means it's going to continue going down. So I know that I'll start with negative infinity. But as I rise, it is going to stop, and the highest it's going to be on this particular function is up at -2. Oops. And so notice how, because it's included, we will put a bracket with it. If we're looking at x-intercepts, I see that nowhere in this graph will it ever touch the x-axis, so there are none. But if I look at my y-intercept, where it's touching the y-axis, it's the ordered pair of 0, -2. Remember, when it says f of 2, well, 2 is representing your value for x. So I want to go over to 2 on the x-axis and find out where my function is. Well, notice that that would then be located down here. And so my answer would be -2. I'm finding the y value. So then here, this is the opposite. It says find the values for x for which f of x equals -3. So -3 is my y value. We're trying to find all the x values that are at -3. So if I look at -3 on the graph, it looks like the only time where my function is touching -3 is going to be right over here at this point, and that looks like my x value then is -2. If I want to find intervals that are increasing, I'm looking for when is my graph going to be heading up like a positive slope. Well, when we're talking about intervals, it's always in an open interval, so we're only going to use parentheses. I'm looking at the x values that make this happen. So notice that because on the left side, I see an arrow heading down, I know that my x values, as far as it going from low to high, it's going to start at negative infinity. But then the highest point it gets is when your x value is at -1. And once again, I want parentheses around it because we're talking about an open interval. So nothing is being included. If we're talking about an interval on which f decreases, well, I don't see any negative slopes or any slopes that are falling. So in this case, there would be none. And then when it says to find the interval on which f is constant, so remember, to be constant means that you are not increasing, not decreasing, but staying the same. So we want a nice horizontal line. I see that in this graph. Notice that if I look at the x values, it starts at -1 and then it has an arrow, so it just keeps going. But remember, it's an open interval, so I know that I want parentheses, so it goes from -1 to infinity. All right, let's take a look at then the difference quotient. So remember, our difference quotient is f of x plus h minus f of x all over h. I'm giving you a function. So in this case, f of x equals -2x plus 19. Okay, so I'm going to take that, and the very first thing I'm going to do is I'm going to substitute in that x plus h into my function wherever I see an x. So in this case, there's only one x. So I'll only have to substitute in an x plus h one time. So here is that first part of the definition. Then I want to subtract, and then I want to subtract just the function f of x. Well, that is what is given to us. So in parentheses, I am going to be subtracting -2x plus 19. And then this whole thing is all over h. So now if I start simplifying, I want to get rid of the parentheses in the numerator. So I'm going to distribute not once, but then over here, I have to distribute that negative. So we'll end up with a -2x minus 2h plus 19. And then a negative times a negative would then make that a positive 2x minus 19. And this whole thing is all over h. Now that I've gotten rid of the parentheses, I can start combining like terms. I see that I've got a negative 2x and a positive 2x. So those are going to cancel out. I've got a positive 19 and a negative 19. So it looks like those are going to cancel out. So that only leaves us with a negative 2h on the top, and then it's being divided by h. Well, because I have an h divided by h, that means my final answer will then just simplify down to negative 2. Let's look at that definition again. Let's look at it with the function f of x equals x squared minus 4x. So notice that in my function, I have 2 places for x. So when I start my definition and I want the function f of x plus h is going to go into this problem not once, but twice. So I really want x plus h quantity squared minus 4 times the quantity x plus h. Now I want to subtract, and then remember, I want to subtract f of x. Well, f of x is what's given to us. Because there's more than one term for f of x, I have to put that in parentheses. So that stays the same. It's x squared minus 4x. That whole thing is still then all over h. All right, I want to start simplifying, so I got to get rid of the parentheses. If I have x plus h quantity squared, remember, think of that as x plus h times x plus h. So we'll still have to multiply that. I'm going to go ahead and I'm going to distribute that negative 4. So we'll have a negative 4x minus 4h. I'm also going to distribute that negative. So we'll have a negative x squared plus 4x. This whole thing is still all over h. I'm going to go ahead and multiply those binomials. So we've got x times x, so that's x squared, x times h, and then an h times x. So we technically then have 2 hx or xh's. Then I have h times h, which is h squared. If I look at the rest of my terms in the numerator, notice that I've got a negative 4x and a positive 4x. So those would cancel. So I still just then have a minus 4h minus x squared. And then this is all over h. So now I don't have any parentheses. I want to start seeing if I can combine any more like terms. Well, it looks like there's an x squared and a negative x squared. So those end up simplifying out. So I have a 2hx plus an h squared minus a 4h, and this whole thing's all over h. Every single term in the numerator looks like they have something in common. They have an h. So I'm going to factor that out, which then leaves you with a 2x plus h minus 4, and this whole thing's all over h. And now because I have multiplication on the top and I've got an h on both the top and the bottom, those are going to simplify. So my final answer is 2x plus h minus 4. Let's look at one more example. So same definition, here's a new function where you want f of x to equal 6x squared plus 9x minus 1. So once again, I'm going to start with the first half of my definition. F of x plus h looks like there's 2 places where I'm going to have to substitute in the x plus h. So we'll have the 6, then we'll have x plus h quantity squared, plus 9 times x plus h minus 1. So there's my new function with that first half of the definition. Now I want to subtract, and now I want to subtract f of x. So because f of x has 3 terms, I get to keep them all the same, but I want to put them in parentheses because I know that I have to subtract that whole thing. And this is all over h. Okay, once again, my goal is to first get rid of the parentheses. So in the first half, keep the 6. Don't forget that when you square something, you multiply it by itself. So I'm going to write that out twice. I'm going to distribute the 9. So we'll have plus 9x plus 9h. We still have minus 1. And then over here, I'm going to distribute that negative. So we'll have a negative 6x squared minus 9x plus 1. That whole thing is all over h. Because I still have parentheses, I'm going to keep the 6, but now I'm going to start multiplying. X times x is x squared. x times h, so we'll have an xh, and then h times x, so that means we'll have 2 xh's, and then h times h is h squared. I see that I have a 9x and a negative 9x. I have a negative 1 and a positive 1. So then I still just have a 9h minus 6x squared. This is still all over h. Now that I've multiplied out the two binomials, I can drop the parentheses once I distribute that 6 to everything in parentheses. So now I'll have a 6x squared plus 12xh plus 6h squared. Still have plus 9h minus 6x squared. This whole thing is still all over h. If I look for my like terms, I see that I have a positive 6x squared and a negative 6x squared. So then that still leaves you with that 12xh, the 6h squared, and the 9h. But all of those have something in common. They all have an h. So I'm going to factor that out. So then that would leave us with a 12x plus 6h plus 9. And then because there's an h now in the top as well as the bottom, looks like my final answer is 12x plus 6h plus 9.